Today we're going to continue chapter 4, which today we are going to look at rational functions. So in 4.1 we looked at reciprocal functions. Now we're going to look at rational functions. And so we're going to start again with a definition. So rational function, what is that? Well, it is a function where you have a polynomial. So we're just going to use p of x to represent the first polynomial, divided by another polynomial that we will just use q of x for. One thing we learned yesterday and over our math career is that we cannot divide by 0. So q of x, whatever that is on the bottom, cannot equal 0. Okay, and then again, we said it, but just a side note, p of x and q of x are just representing polynomials. All right, so again, rational function is going to be a polynomial divided by a polynomial. Remember, binomials, trinomials, all of those are polynomials. So how can we tell the transformations from a rational function? So yesterday, or whatever day you watched the last video, we talked about reciprocal functions, and I'll just go ahead and scroll back up to that part. So we talked about the h being the horizontal one and the k being that one, and we could see it. For rational functions, we actually have to do some math prior steps to get it so that we can see the transformations. And what I mean by that is we have to use a method called synthetic division. So use synthetic division to rewrite as a reciprocal function. Okay, so now we're going to take our rational functions that we get today and we're going to rewrite them as reciprocal functions. So just a reminder that a reciprocal function with the transformations looks like this, where h is our horizontal, so that moves it left or right, and it's opposite of what we see. And then our k value, which tells us the vertical translation, so up or down. And then the new one today is going to be an a here, which would be our dilation. So again, a is our dilation. So it's going to make it shrink, stretch, so wider or skinnier, wider or skinnier for that dilation. So let's just jump in. Another thing is, if there is a negative in the front right here, it would reflect. Okay, so today our main goal is just going to be to identify all those. We're not necessarily going to graph it by hand. I recommend just for today to use desmos.com and use that graphing tool there. So let's jump into example 1. Let g of x equal 3x plus 5 divided by x plus 1. So we have a rational function. It looks like a polynomial over another polynomial. So we are given the first step to rewrite it as a reciprocal function. So we said that we were going to use synthetic division to do that. And if we remember from our previous lesson, synthetic division is what I called a magic trick to long division. So we start by putting the opposite of what is here inside this box right here. Whoops. So -1 inside. And then we take our coefficients and we put them up top. So 3 and 5 were our coefficients. And then we bring down that first number. And then we take this number and we multiply it by what's in the box. So 3 times -1, we get -3. And then we add those and we get 5 plus a -3 would be 2. And now we're done. And so from our synthetic division, we said the last number on the right side is our remainder, and then it goes constant. And if we had more, it would go x, and then x squared, and so on. So if I take this and I go ahead and rewrite it, I have my constant of 3 plus my remainder of 2 over what we divided by. So we divided by x plus 1. So that's what I'm going to write here. X plus 1. Okay, so again, I got that x plus 1 because that's what we divided by. Well, this looks very similar to what we talked about in 4.1 or to this equation up here above. The only difference is the constant is on the left side, so we can rewrite it so that it's the same. So I'm just going to rewrite it again. So I'm going to put the fraction in the front, so 2 over x plus 1, and then add the 3 on this side. So now I can see my transformations. I have a 1 right here. So remember, it's opposite, so it's saying plus 1, so that's actually left 1. And then I can see my k value now in this, which is right here, and that says plus 3, so it's going to move it up 3. And then the other thing I see is that my top number, my numerator, is a 2 and not a 1, so that means I have a dilation. So it's dilated by 2. Okay, and then if you go to Desmos and you type this in, you'll see that it kind of stretches. Normally our points would be, 1 over and 1 up from the axes or the asymptotes, but now it's going to be a little bit different. Then again, I would just recommend that you pause the video and you try doing all this on your own. Again, today we didn't focus on graphing. We just focused on listing and rewriting the function. So rewriting in from a rational to a reciprocal, and then identifying the transformations. That's our key parts today. And then also just being able to state these. So go ahead and pause the video and try those, and then check your answers. So I'm going to start by rewriting it. And so I'm going to do some synthetic division. My magic. So I have a -2, and so a 2 goes here because we do opposite. And then I need my coefficients. So 4 and -11. 4, -11. Then I'm going to bring down the first number. So I have 4. And then I do my multiplication, so 4 times 2 would be 8, and then I add those, and that -11 plus 8 would be -3. And now I have it so that I can rewrite it. Again, I have a remainder of -3 over what I divided by, which was x minus 2, and then plus my constant. So this time I rewrote it so that my fraction was first. So I wrote it right to left because I remembered that I want it in this format and the fraction is first in this format. So now my h value is 2. So I'm moving the function right to. And if we remember from yesterday, we also said that when we move it right to, it creates that vertical asymptote right there. So I'm going to go ahead and fill in down below with it. So vertical asymptote, I said, is going to be at x equals 2. Then I can also see my k value, which says plus 4. So I go up 4, which means there's that vertical asymptote or horizontal asymptote there at y equals 4. So I'm going to go ahead and fill that in as I go. And then it moves it up 4. Okay. And then I want to make sure there's nothing else there. Well, there's a negative here. And so that means it reflects the x-axis. And then I also have a 3 here. There's all sorts of transformations going on here. So I also dilate by 3. Okay. And then domain and range, remember domain is all our x values, and I can plug in any x value I want except for 2. So my domain is all real numbers except x does not or cannot equal 2. And then my range is all real numbers. But we can't have it equal to 4, so y cannot equal 4. Okay. And then for the x and y intercepts, you would graph it. And then remember, y-intercepts are when it's touching this line right here. And then x-intercepts are when it's touching this line. So this line is x-intercepts. This line would be y-intercepts. And what you would do is you would just go to Desmos, type in this function, and I'll show you in class how to do that. But that's it for today. 4.2 day 2 will be up in a little bit. Thanks, everyone.